Let's learn how to factor four-term polynomials using a technique called factoring by grouping. Remember, factor means rewriting a polynomial or an algebraic expression into the product of two algebraic expressions. The unfactored form and the factored form must be equal to each other. Whenever you're asked to solve a factoring problem, you can work through this factoring flowchart. The first thing to do is factor out the GCF. That was covered in a previous video. Next, determine how many terms are left for the inside polynomial. In this video, we're going to discuss what to do if there's four terms in your polynomial. You'll use a technique called factoring by grouping. So how do you do this technique? Here's the steps to do factoring by grouping. As always, we should always check for GCF for all the terms before we proceed with any other method. This is what our factoring flowchart shows us. But once you do that, then the actual factor by grouping steps start. You group the terms into two groups. Factor the GCF from each group. Then look for a common binomial factor. Remember, we use factor by grouping on four-term polynomials. Let's look at an example. Let's factor this polynomial. Now, we're asked to factor a polynomial. What should be our first step? Refer to the factoring flowchart. The first step is always factor out the GCF. We have four terms. What's the GCF of these four terms? The GCF is 1. If the GCF is 1, this is trivial. We don't need to do anything. If the GCF is not 1, then we need to factor it out. But in this case, the GCF is 1, so we can proceed with step 2. Let's look at the factoring flowchart again. Once we factor out the GCF, what do we do next? Well, we determine the number of terms our polynomial has. That tells us which way to go. Remember, we said our polynomial had 4 terms, which means we need to use factoring by grouping. Here's the steps for factoring by grouping. We already did step 1, which is just check for GCF. Step 2, group the terms into 2 pairs. We have 4 terms total. Let's group them into 2 pairs. This is how I've done the grouping. You can choose the grouping any way you want. Sometimes factor by grouping will work with some arrangement of pairs and not with other arrangement of pairs. So you notice in step 4 it says, if it doesn't work, try rearranging the pairs and then try again. So I'll try these pairs, but if they don't work, then we could try different pairs. Step 3, factor the GCF from each pair. So this is different than what we were doing in step 1. Step 1, we were looking at the GCF for the entire polynomial. Step 3, once we group the terms into pairs, we're just looking for the GCF for each pair. Remember, we said the whole polynomial didn't have a GCF other than 1. But each of these pairs might have a GCF. Let's look at the first pair. Is there a GCF? Yes, the GCF is y. I factor the GCF from that first pair and it gives me this. If you need help on how to factor out a GCF, please refer to the previous video on that topic. The GCF for the second pair is 3. So I can factor the GCF from these 2 terms and it gives me this for my second pairs. Now in between the first pair and the second pair is a plus. That plus is very important and you need to write it. If you don't write it, it's wrong. Without that plus, it would be indicating implicit multiplication, which is not what we have right now. we have a plus in between. This is not, if you look at the entire polynomial as a whole, it's not in factored form because we have two terms separated by a plus. Now notice what happened. We started with 4 terms. We split those 4 terms into 2 pairs, factored the GCF from each pair, which reduced the total number of terms from 4 into 2. But this is still not factored because there's a plus in between those 2 terms. So what do we do now? Step 4. Look for a common binomial factor. Binomial means 2 terms. If it's there, factor it out. Do we have a common factor between these 2 terms? Yes. The GCF is x minus 5. Let's factor that GCF from these 2 terms. Doing so gives us this. How did I get this? I factored the GCF out. I covered this in a previous video on the topic. So if you need help with that, please look back at that previous video. Remember, we take the GCF, put it on the outside, draw a new set of parentheses, then take each term, divide it by the GCF. When you take this first term divided by x minus 5, you're only left with a y, so that goes there. Take the second term, divide by the GCF. You're only left with a 3, that goes there. Now we have the polynomial in factored form. So this is our factorization. So that's our answer. Now let's check and see if the factorization is correct. Remember, the factored form must be equal to the unfactored form. To check, we can multiply this out. To multiply, we can use the distributive property to multiply every term by every term, which gives us this. Does this equal the unfactored form? Yes. So it tells us our factorization is correct. Let's look at one more example. We're asked to factor this polynomial. What's the first step when we're asked to factor a polynomial? If you look at our factoring flowchart, the first step is factor out the GCF. So remember to always check for that. We're talking about the entire polynomial, every single term. Let's look at the numbers and the variables to find the GCF. For the numbers, we have 15, 10, 6, and 4. 4 only has factors of 2. 15 does not have factors of 2. Therefore, there's no GCF other than 1 for the numbers. However, for the variables, we have a GCF of x. So the GCF of the entire polynomial is x. Let's factor that out. Doing so gives us this factored polynomial. Now, this is factored because it's written as a product of this algebraic expression x times this algebraic expression. However, oftentimes a polynomial can be factored, but it's not completely factored. We want to always write a polynomial completely factored, which means there's no more factorization that can be done. So yes, this is factored. However, it's not completely factored, so we must keep going. To keep going, we look at what's left on the inside and ask how many terms do we have here? There's 4 terms. According to our factoring flowchart, if there's 4 terms, we need to use factoring by grouping. Remember the steps for factoring by grouping. We already did step 1. Step 2, group the terms into 2 pairs. Now, we can just focus on the inside polynomial for a second, but when we get done, we have to remember to include the GCF of x on the outside of whatever we get, because that is part of it and is required in order for our answer to be equal to this polynomial we started with. But for now, let's just focus on this inside polynomial. Let's separate the 4 terms into 2 pairs. Now factor the GCF from each pair. The first pair has a GCF of 5x squared. Factoring that out from the pair gives us this. For the second pair, we can think of the GCF as 2. Factoring that out from the pair gives us this. Now what's in between these two terms? It's very important. There's a plus. You have to write that. Now we have two terms, this term and this term. Now we do step 4, look for a common binomial between the two terms. Do we have a common binomial? Are these the same? No, they're not, because this one has a positive 3x, this one has a negative 3x, and same with the 2. So if you notice, they're actually opposites. Opposites are where you have the same magnitude, but one is the positive version and the other is the negative version. So even though these are not the same, and thus we cannot factor it out, we can make it the same by making this one small change. Instead of factoring out a 2 from the second pair, let's factor out a negative 2. How does that change the second term? Well, I put a negative 2 on the outside of parentheses. Then I divide each of these terms by negative 2, which gives me negative 6x divided by negative 2, positive 3x for the first term. Positive 4 divided by negative 2 gives me negative 2 for the second term. And just a little observation, typically when you're factoring out a GCF, if your leading term is negative, then you should make your GCF negative as well. In this case, the leading term was negative 6x, so it was probably a good idea from the start to make the GCF negative. Now, let's look at what happens in between the two terms. We have plus a minus. Plus a minus you can rewrite as simply minus. So we make that simplification. Now let's go back to step 4 and see if we have that common binomial factor. Are these two factors the same? Yes. So now we can factor them out. The GCF is 3x minus 2. Let's factor it out. And we get this. Now we've factored by grouping the 4-term polynomial that was on the inside. But what's our final answer? Well, we have to include the x that we factored out at the very beginning. So what did we just do? We determined that this inside polynomial factors into this. But the x on the outside still has to be there. So this is our final answer. Now, as always, we should check our factorization to make sure it works. Remember, to check our factorization, we take the factored form, multiply it out, and it should equal the unfactored form. Now, to multiply this out, we have 3 polynomials multiplied together, this, this, and this. So you can do it in 2 steps. You can perform the multiplication of this polynomial and this polynomial first, which gives us this, and then finally we can perform the multiplication of this polynomial and this polynomial, which gives us this. Now the question is, does this equal the starting unfactored form? Yes. Therefore, our factorization is correct. In this video, we learned how to factor a 4-term polynomial using the grouping method.